Welcome back, and I do hope you and your family are keeping well. So we're going to do a bit of an experiment today, and one you would have done if you were here, and we're going to be looking at a little bit more detail at the thermistor. So if you remember, the thermistor is one of these devices which, as the temperature goes up, the resistance goes down. And our laboratory thermistors look a little bit like this. They're kind of electronic thermometers. And in the end of this glass tube is the material that's the thermistor. So when we heat it up, it's going to conduct electricity better. But what I'd like to do today is to see how its resistance changes with temperature. So I've built a fairly simple piece of apparatus. I've got a power supply, and here's an electrical heater. And this electrical heater is just sitting in a beaker full of water, and it's going to warm the water up slowly. I'd like to know what temperature the water's at different times. So I've got a thermometer here, and I'm going to measure, as the temperature of the water changes, I'm going to measure the resistance of this thermistor. So the thermistor can go in the water, and I've got a multimeter here set to resistance. So this is going to directly measure the resistance of the thermistor. Now I could set up a battery, a voltmeter and an ammeter, and use V equals IR, in other words, R equals V over I, to calculate the resistance every time. But here's the easy way. Just use a multimeter, and this is calculating the resistance for me straight away. At the moment, it's reading 6,260 ohms, so the resistance is quite high. So what we're going to do is we're going to turn on the power supply. I'm going to take readings of temperature as the temperature rises, and I'm going to record what the resistance is of the thermistor at those different temperatures. And then what I'd like to do is I'd like to plot a graph of how does the resistance of the thermistor change with temperature. So let's get started with our experiment. So I've got myself a little table of data here, and we can take our first value even with the power supply turned off. So I've got a temperature of the water of 18 degrees centigrade. So 18. And the resistance of the thermistor measured is 6,230. 6,230 ohms. So what I'll do now is turn the power supply on, warm the water up a little bit, and see what the resistance of the thermistor is as the temperature gets higher and higher. So I've left it on for a short period of time, made sure I've given it a bit of a stir too, and it's at 25 degrees centigrade, and the resistance of the thermistor is 3,920. 3,920 ohms. So its resistance has definitely gone down. Let's keep heating up the water and get some more values of temperature and resistance, and that will enable us to graph our results. So got the water in the beaker up to 60 degrees centigrade, and the resistance of the thermistor was 1,150 ohms. So we started off at 18 degrees C with over 6,000 ohms, and we got up to 60 degrees C and it dropped to just about 1,000 ohms. So it shows really clearly that as the temperature goes up, the resistance goes down. What I'm going to do is I'm going to put these figures on the screen, and I'd like you to plot a graph of temperature on the x-axis against resistance on the y-axis. Any piece of paper will do. It doesn't matter if it's lined paper or what have you. It's the shape that's important. I think what I'll do is I'll put the resistances in kilo ohms to make it a little bit easier, and then we'll analyse the shape that we got. So I hope you've now plotted your thermistor data and you got a graph much as we expected. So you put your temperature in degrees C on this axis and you put your resistance, got to be a bit careful this time, it's in kilo ohms on the y-axis. And when I did it, I noticed we got a slight anomaly in our points. So there was a slight sort of drop and then it sort of did this sort of thing. Okay, so that was slightly anomalous, that one. But line of best fit, so I'll come around this side. And there we go. We can see that as the temperature increased, the resistance of the thermistor decreased. Now, what we didn't do was then put the thermistor into a drink or something, some coffee or tea or something, without the thermometer. And what we could have done then is looked at the resistance of the thermistor. So maybe it was a value here. Went across to the line, go down, and that would be the temperature of the liquid that we measured. So, if you remember, the behaviour of the thermistor is like this because it's made of a material that conducts electricity better when it's warmer. And this is because the material in there has electrons that are freed up. So as you heat up the material, more and more free electrons are able to move through it, and so its resistance goes down. So we've had a good look at the thermistor there. An experiment that we do with the thermistor to get this graph shape, okay, and most importantly, how we would use this graph that if we knew the resistance of the thermistor, what the unknown temperature is. So, I hope you found that useful. I look forward to seeing you for another lesson soon.